Welcome back, everyone. So today we're actually picking up exactly where we left off yesterday. If you caught part 1 of this explainer, you know we took a deep dive into deep evolutionary time, looking at the very earliest hominids. Well, today is the continuation. We are tracing our journey forward, going from early bipedal apes all the way to, well, us, modern humans. Get ready, because we're going to look at some absolutely massive, groundbreaking changes in how our ancestors moved, thought, and survived.
All right, let's just jump right into the agenda. Today, we're looking at how the human story continues. We'll meet the Tang child, check out early tools and cognitive leaps, enter the era of Homo erectus, and then finally compare Homo erectus directly against Homo sapiens.
So we are bridging a really massive gap today. As you can see on this timeline, we're starting way back, millions of years ago with early South African hominids. Then we're moving to the emergence of Homo erectus roughly 1.9 million years ago, before finally arriving at the endurance-running modern humans we are today, right around the 300,000-year mark. Honestly, it is just a timeline of pure dynamic adaptation.
Okay, let's get right into part 1. The human story continues.
The crucial point where we actually resume our story today is in the late Pleistocene of South Africa. Now, 3.67 million years. That is a staggering number. That represents the age of a truly remarkable fossil nicknamed Littlefoot. And what's wild is that this specimen preserves an astonishing 90% of its skeleton. Having a mostly complete skeleton like this is a huge deal because it definitively proves these early ancestors were habitual bipeds. The trabecular bone, you know, that spongy, shock-absorbing tissue inside the hip joint, it's distinctly human-like. That means they were literally built for walking upright, not just swinging around in the trees.
But what's really fascinating about this era is the sheer mix of features these early hominins actually had. Like, even though Australopithecus africanus walked upright on a stiff midfoot, they didn't have a fully separated big toe like an ape, and they actually pushed off using the side of their foot. Plus, they still held on to some ape-like upper body traits. And you might be wondering, why? Well, it allowed them to be highly adaptable generalists. If the climate suddenly shifted, no problem. They could still forage for everything from tough roots and savannaceae for grasses all the way to hard seeds. They were pretty small, with males averaging just about 4 foot 7 inches, but man, they were incredibly resilient survivors.
All right, moving right along to Section 2. Meet the Tang child.
So, back in 1924, a skull was pulled from a limestone quarry in Tong, South Africa. Anatomist Raymond Dart identified this 2.8 million-year-old juvenile skull and immediately recognized it was a bipedal creature, but one with a really small brain. Now here's why that's a game-changer. At the time, the entire scientific consensus firmly believed that humans evolved in Europe or Asia, and that big brains evolved before walking upright. The Tang child completely flipped that on its head. It was literally the very first evidence showing that humanity actually originated in Africa, proving we were walking upright long before our brains ever got big. No wonder Dean Falk calls it the most important anthropological fossil of the 20th century.
But looking beyond just the scientific importance for a second, the Tang child gives us a really dramatic, honestly kind of terrifying window into prehistoric life. Based on its dental enamel, researchers figured out this toddler was only about 3 to 4 years old. And in a crazy twist of fate, damage marks found underneath the eye sockets revealed that this little bipedal kid didn't die of natural causes. It was actually snatched up by an ancient bird of prey, like an eagle. It's a pretty stark reminder that, well, long before we ruled the world, our early ancestors were very much on the menu.
Which brings us smoothly to Section 3, Tools and Cognitive Leaps.
So how exactly do we go from being hunted prey to being the apex predator? Well, the answer really starts with technology. Specifically, the Acheulean tool industry. We aren't just talking about blindly smashing rocks together anymore. This was a major technological innovation. We're talking large, heavy-duty stone tools like hand axes and cleavers. These were used for butchery, processing tough vegetables, even woodworking. But the invention of these tools wasn't just about, getting sharper edges. It was actually a physical manifestation of a massive cognitive leap happening right inside our ancestors' skulls.
And here is the really crucial point. This toolmaking actively changed our biology. It's fascinating. Modern neuroimaging studies of people today replicating these ancient tools show that chipping away at these stones actively engages the motor regions and the prefrontal cortex. It requires complex visuospatial processing and multi-step hierarchical action planning. Basically, you have to literally see the axe hidden inside the stone before you even start making it.
So research strongly suggests that as our tools became more complex, our brains were quite literally wiring themselves for the exact same processing required for the early stages of language and advanced social cognition. It's like a giant puzzle coming together.
And that technological mastery ushers in Section 4. Enter Homo erectus.
Emerging around 1.9 million years ago, Homo erectus is where things start to look, well, very familiar to us. Discoveries like the famous Turkana boy, which is a remarkably complete 1.5 million-year-old skeleton found in Kenya, they show us a hominin that finally looks a whole lot like a modern human. Sure, they still had unprecedented, faster, somewhat ape-like growth patterns, but their bodies were absolutely built for the expanding savannas. They were becoming a major predator, acting essentially as the very first true hunter-gatherers. They utilized those advanced tools we just talked about to thrive, even as global climates were fluctuating all over the place.
And you can see exactly why this evolutionary stage is such a big deal when we look at this chart of brain volume. Homo erectus represents a massive, nearly twofold leap in brain capacity compared to earlier hominids like Australopithecus africanus. I mean, look at that jump, from about 465 cubic centimeters all the way up to an average of 900 in erectus. That is huge. This was basically the ultimate biological hardware upgrade. It's what allowed for organized hunting, more complex social structures, and eventually our massive expansion out of Africa and into Eurasia. All right, that brings us to our fifth and final section, Erectus versus Homo Sapiens.
So if Erectus was so advanced, how do we hold up when we place them right next to us? Well, when you look at the skeletons side by side, the differences are pretty striking. Homo erectus was built for absolute power. They had shorter legs, longer arms, thick, robust bones, and a barrel-shaped rib cage. But over time, our bodies, Homo sapiens, evolved an elliptical rib cage, far more slender bones, and critically, much longer legs with shorter arms. We essentially sacrificed pure brute strength to become completely optimized for highly efficient long-distance endurance running. We basically traded the sheer muscle power needed to wrestle a predator for the ability to run marathons.
And as this table perfectly breaks down, the final architectural shifts in our core structure are just as pronounced. Up top, Homo erectus had a low, elongated cranial vault with a receding forehead and a super prominent brow. We, on the other hand, adopted a high globular brain case to house those massive 1,350 cubic centimeter brains, along with a vertical forehead and a much smaller brow. And then down below, the erectus pelvis was narrow and long, whereas ours became broad and short. That's a really crucial shift because it provided way better support for our internal organs during all that upright endurance running we were doing.
Honestly, as we look at the bones of Homo erectus, we're basically looking at the rough draft of ourselves. I mean, they walked the earth for well over 1 million years. They were highly successful and incredibly adaptable. Which leaves us with a fascinating mystery to wrap up today's continuation of The Explainer. What extreme environmental pressures, what specific climatic volatilities, or social dynamics finally forced that robust, heavy-browed hunter to shed its thick bones, expand its brain case, and evolve into the modern human reading this slide right now? It's a pretty profound question to ponder as we keep uncovering the secrets of our origins. So think on that. Thanks so much for joining me today, and as always, keep questioning the story of us.